If a tree falls in a forest and no one is around to hear it, does it make a sound? You've heard this question before. Most of us have. It sounds like a riddle, a clever philosophical trick, something meant to tease the mind, not change it. But I want to slow this down, because once we look at this question through the lens of modern physics, it stops being a word game. It becomes unsettling. Imagine a forest, not a metaphorical one, a real forest. Wind moving through the leaves, soil damp beneath the roots, birds somewhere far off. Now imagine a tree begins to fall. Branches crack. The trunk tilts. Gravity does what gravity does. But no one is there. No human ears. No animal nearby. No recording device. Just the forest. So what actually happens? Most people answer quickly. Of course it makes a sound. Sound is just air vibrating. And at a classical level, that feels right. But physics, especially quantum physics, has a way of quietly undoing our certainty. Because when we zoom in far enough, reality stops behaving like common sense. In everyday life, we assume the world exists independently of us. Objects have properties whether we look at them or not. Trees fall. Rocks roll. Waves crash. Reality feels solid, continuous, objective. But early in the 20th century, physicists began discovering something deeply strange. At smallest scales, atoms, electrons, photons, things do not behave like solid objects at all. They behave like possibilities. An electron, for example, doesn't have a definite position until it's measured. Before that, it exists as a spread of probabilities, what physicists call a wave function. This isn't philosophy. This is experiment. In the famous double-slit experiment, first explored seriously in the 1920s, particles behave like waves when unobserved, and like particles when observed. Not metaphorically, literally. When no measurement is made, an electron passes through both slits at once as a probability wave. When a detector is added, the wave collapses, and the electron behaves like a particle. The act of observation changes the outcome. This deeply disturbed the founders of quantum mechanics. Niels Bohr argued that physical properties don't exist in a definite way until measured. Werner Heisenberg showed that certain pairs of properties, like position and momentum, can't both be known at the same time. And Erwin Schrödinger illustrated the absurdity of this with his now famous cat, neither alive nor dead until observed. Reality, at its core, appeared to be incomplete without interaction. So now let's return to the tree. Here's the uncomfortable question quantum mechanics raises. If microscopic systems don't have definite properties without interaction, why should macroscopic systems be fundamentally different? We like to say they are. We like to believe size somehow rescues objectivity. But physics doesn't actually give us a clean boundary. There is no official line in nature where quantum weirdness stops and classical certainty begins. Instead, physicists talk about something called decoherence. Decoherence explains how quantum systems appear classical when they interact with their environment. Air molecules, photons, thermal noise. It's a powerful idea, developed by researchers like Wojciech Zurek. But notice what's happening. Reality becomes real, not in isolation, but through interaction. Not necessarily conscious observation, but interaction nonetheless. So when the tree falls, its vibrations interact with air molecules. Those molecules interact with others. Energy disperses. From a physical standpoint, yes, vibrations occur. But is that sound? Sound, as we experience it, is not just vibration. Sound is vibration interpreted by a nervous system. No ears, no auditory cortex, no experience of sound, which raises a subtle but crucial distinction. The universe may contain physical processes without containing experience. This is where the falling tree question quietly shifts from physics to consciousness. Because at its heart, it's not really asking about trees. It's asking whether reality exists independently of experience, or whether experience plays a fundamental role in what becomes real. Some physicists are careful here. They'll say, quantum mechanics doesn't require consciousness, measurement can be done by any interaction. And that's true within standard interpretations. But others have noticed something harder to dismiss, that the universe seems strangely tuned for observation. John Wheeler, one of the most influential physicists of the 20th century, proposed what he called the participatory universe. In Wheeler's view, observers are not passive spectators. They are part of the process by which reality takes shape. His famous phrase was simple and unsettling. Reality is not given, it is participatory. Not created by us, but completed through interaction. Wheeler even suggested that the universe, in some sense, requires observers to bring its history into being. That's a radical idea, but it comes from a serious physicist who helped build quantum theory and general relativity. So again, back to the tree. If no conscious system ever registers the event, does it exist as an experience? Or does it exist only as unrealized potential? Some interpretations go even further. The many worlds interpretation, developed by Hugh Everett, avoids collapse entirely. In this view, the tree both makes a sound and doesn't, in different branches of the universal wave function. Every possibility exists. Observation doesn't create reality. It selects which branch you experience. But even here, experience matters. Reality may be vast and branching, but your reality, the one you live inside, is defined by interaction. And that brings us to a deeper layer of the question. What do we mean by exists? Does something exist if it never enters experience? If it never influences awareness? If it never becomes information for any conscious system? Physicist Carlo Rovelli, through his relational interpretation of quantum mechanics, suggests that properties don't exist absolutely, only in relation. There is no God's eye view, no absolute state of things, only relationships. In that framework, the tree's fall exists relative to the air, the ground, the molecules, but not relative to a conscious observer who never encounters it. Reality becomes contextual, relational, and suddenly the forest feels very different. It's no longer a stage where events simply happen. It's a web of interactions, some of which crystallize into experience, and some of which fade into statistical background. The universe doesn't deny the tree's fall, but it may not grant it the status we casually assume. Not sound as lived reality, not event as meaning, just process, potential, unexpressed information. And if that's true, then the falling tree question isn't trivial at all. It's asking whether existence is something that merely happens, or something that appears, whether reality is fully formed without observers, or whether observers are woven into its structure. And we haven't even reached the most uncomfortable part yet. Because once we accept that interaction matters, the next question becomes unavoidable. What kind of interaction actually stabilizes reality? Is it any interaction? Or something more? That's where things get even stranger. Because in the next part, we'll explore whether consciousness itself, not just measurement devices or air molecules, plays a deeper role than physics has been willing to admit. We'll look at ideas from Roger Penrose, the limits of decoherence, and why some physicists believe the universe may not fully decide what happens until awareness enters the picture. And when we do, the forest will no longer feel empty. The forest will no longer feel empty. Because once we start questioning whether interaction gives reality its shape, we are forced to confront a possibility that physics has circled for decades but rarely states out loud. That consciousness itself may not be a late arrival in the universe. It may be woven into the way reality resolves. For a long time, physics tried to avoid this conclusion, not because the math rejected it, but because the implication was uncomfortable. Science was built on the idea that the universe runs perfectly well without us. That consciousness is a byproduct, an accident biology, something that happens after the real work is done. But quantum theory keeps pulling us back to the same unresolved tension. Measurements matter. Interactions matter. Information matters. And when you ask what kind of system can register information in a meaningful way, You are no longer talking about rocks or air molecules. You are talking about awareness. This is where Roger Penrose enters the story. Penrose, a Nobel Prize-winning physicist, has long argued that standard quantum mechanics may be incomplete. Not wrong. Incomplete. In his view, the universe cannot rely solely on decoherence and environmental noise to explain how possibilities turn into definite outcomes. Something else has to happen. Something that selects. Something that ends the ambiguity. Penrose proposed that wave function collapse is a real physical process, not just a mathematical update, and that it may be tied to gravity itself. According to his idea, quantum superpositions become unstable when they involve enough mass or space-time curvature. At a certain threshold, reality chooses. Not because someone looks, but because the universe cannot sustain the ambiguity any longer. This is known as objective reduction. But Penrose didn't stop there. He asked a deeper question. If collapse is a real physical event, and if conscious experience feels discrete, unified, and moment-based, could the two be related? Together with anesthesiologist Stuart Hameroff, he proposed a controversial but fascinating idea known as ORCH-OR, orchestrated objective reduction. The suggestion is not that consciousness magically collapses reality. It's subtler than that. The proposal is that conscious moments may arise from quantum processes occurring inside neurons, specifically within structures called microtubules. In this view, awareness is not an afterthought. It is a natural outcome of quantum processes resolving into definite states. Reality doesn't just happen and then get observed. Observation may be one of the ways reality finishes happening. Now, the idea is debated strongly. Many physicists reject it. Many neuroscientists are skeptical. But here's the important point. It exists. Serious scientists are willing to entertain the idea that consciousness may not sit outside physics, looking in. It may be part of the mechanism. So let's return, again, to the tree. Not as a metaphor. As a test case. The tree falls. Vibrations move through air. Energy disperses. Quantum interactions cascade through molecules, fields, and space-time. But no conscious system ever registers the event. No experience forms. No memory. No information enters awareness. Did the universe fully decide what happened? Or did it merely process a possibility that never became meaning? This is where the question stops being about sound and becomes about existence. Because sound, as lived reality, is not vibration. It is vibration experienced. Without experience, there is no hearing. Without hearing, there is no sound. Only motion. Only math. Only fields evolving according to equations. Which raises a provocative possibility. The universe may be full of events that never quite become real in the way we intuitively mean real. They occur physically. But they never crystallize into narrative, memory, or meaning. They never enter the stream of experience. They are unresolved chapters. And if that's true, then awareness is not just something that happens inside the universe. It is something that gives the universe texture, definition, story. This idea echoes through multiple interpretations of physics. In relational quantum mechanics, properties exist only relative to other systems. In Wheeler's participatory universe, observers help bring reality into being. In information-based approaches, reality is defined not by matter alone, but by what can be known. Even in classical physics, once you strip it down far enough, everything reduces to relationships, forces, interactions, exchanges. Nothing exists in isolation. So perhaps the deepest mistake we make is imagining a universe that exists fully formed, waiting to be noticed, instead of a universe that is continually coming into focus through interaction, through registration, through experience. Which brings us back, one final time, to the forest. Imagine the tree falling again. But this time, imagine a fox nearby, or an owl, or a human walking just out of sight. Suddenly the event changes. Not physically. The vibrations are the same. But ontologically, it becomes sound. It becomes memory. It becomes part of the lived universe. The tree's fall now exists not just as motion, but as experience. And that difference matters, because meaning does not arise from equations. It arises from awareness, encountering change. So does the tree make a sound if no one is there to hear it? At one level, vibrations occur. At another, nothing is heard. And at the deepest level, the question may be backwards. The more precise question might be this: does the universe need experience to become fully real? Or is experience simply one more ripple in an already complete world? Quantum physics does not give us a final answer, but it refuses to let us pretend the question is trivial. It insists that observation, interaction, and information are not side effects. They are central. And once you see that, the forest is never silent again. Not because it is full of sound, but because it is full of possibility, waiting to be met.